Hello everyone, and welcome to a little video series I'm putting together where we're going to develop a custom environment for deep reinforcement learning as applied to portfolio optimization. This video series actually spans several different repos that we put together, and it's really a continuation of another video series that we did last year, which is deep reinforcement learning for portfolio optimization. When we ended that last video series, there was a general conclusion that a lot of the reinforcement learning frameworks that have been built don't really apply very well to the finance world, or I should say the portfolio optimization. In particular, we use the RL Coach in SageMaker, and this is a framework for reinforcement learning. It's actually a very good one if you have a kind of static environment. So here in any of the traditional reinforcement learning, you have an agent, you're trying to train, it's trying to build up policies where it determines what actions to take depending on the current state that it sees. And again, it's trying to maximize that sum of discounted rewards that it receives from the environment. So in the trading environment, of course, it's going to be changes in the portfolio value. However, in this, there's a kind of baked-in assumption that your environment is pretty static. So if you're building an agent to play chess, the rules of chess aren't changing midstream. However, of course, as we know, we just went through COVID-19, where if we built an agent, for instance, up to 2019, and then we just continued to trade it, assuming that the environment would be the same, it would have done very poorly through March of 2020. So the idea here is that we have this one training and evaluation period. It's kind of not broken up. So, the traditional one where you may take 10 years, train an agent, and see how well it runs in the following 2 years. That's just simply not realistic. If you had a trader that kind of learned a bunch of stuff and then stopped learning and just kept making the same trades, they wouldn't do very well. They have to continuously adapt. So like real life, we're going to only get one pass through time. So you can't learn about the future and then come back. So one pass through time, but every day you're going to reevaluate your all of the history that you have, and you're going to retrain the agent. It's going to make trades. The following day it gets the feedback, retrain. So there's this continuous retraining and evaluation. So there's only one evaluation period and there's only one training period, which kind of just continuously steps through time. So to do that, again, we use these standard frameworks before, but we can't do that. So here what we've got to do is we've got to kind of get into Docker, where we build a custom container for our training environment. So I'm not going to get into any sort of details about Docker. If you're not familiar with it, I highly recommend looking into it. It's a great way to kind of encapsulate your code. But the idea here is we develop a training environment, a code base, and then we package it up in a nice little package, which is called a container. And then we use the Amazon Elastic Container Registry. So again, here we build the code, we can test it. We then package it up into a container, put it in the registry, and then from SageMaker, we can kind of go in there and pull that Docker image and evaluate and use it for training and evaluation. So that's what we're going to do here. And I guess if you're not familiar with Docker and ECS and all that sort of stuff, one thing I'll kind of just give a quick shout out here is the Cloud Guru platform. They have a bunch of training. One in particular, this one is specifically for scaling Docker on ECS. So it's very applicable to this particular training video. So once we have this done up for a toy environment, and this is really just laying down the architecture, laying down the foundation where we have Docker and we know how to do those sorts of things. Then we're going to go and constantly make our environment more and more complex. So the first one we're going to do is a trading one, but we're going to have, that the stock history, we're going to generate some fake stock history, and it's going to be just functions that are deterministic and time invariant. So we'll just make up some functions. This is a fantastic world where it's deterministic and time invariant. So we should be able to solve this pretty easily. Again, it's just more about making sure all the systems are working properly. Then we're going to switch over to, we're going to still have a deterministic, but then a time varying function. So now we're going to allow the functions to change over time so that environment changes. So this is a critical step. It's making sure that our agents that we're training are constantly adapting to the new environment that they're faced with. And then the last one, of course, is where we do the real deal. We take the price history and then we just play it forward, right? So we'll just start at the beginning and just play through time. And every day we're going to retrain and we're going to evaluate. And the evaluation, of course, will be the actual training that we're going to do, see how well we're going to do. So with that, I'm going to jump over to another one. This is the SageMaker tennis. So this is, again, in this video, I'm going to break it up into several videos to try to keep them short, one that's easier for me to make, and then it's easier for you guys to watch. So in this particular one, as I mentioned, we're going to just do the tennis Unity environment. And so here there's 8 state variables. So the environment is defined by 8 variables. And then we have 2 different agents, and each agent just allowed to go forwards and up and down. So they have 2 continuous variables in the action space. And to solve this, we're supposed to get 0.5 as a score over 100 consecutive episodes, or basic, games that they continuously play. To start up here, I'm not going to go through it, but I put in how to run locally. I think this is actually a critical step. Me personally, I'm a big fan of SageMaker and everything, but I still like to do all my initial training and development on my own PC. I use PyCharm. I use whatever IDE, of course, that you like. But the idea is here, you can do code checks, you can do all that sort of traditional code development on your local PC, but then when you're ready, you can package it up and move over. So that's basically how to set up a proper Conda environment to do this. This is all, of course, in PyCharm with PyTorch. And then after that, we're really going to get into SageMaker. And this is really where we're going to spend most of our time. The first one, we're going to kind of just go through the building of that Docker image for a CPU. So a lot of different instances, you can use CPU instance or GPU instances. They're slightly different. So we're going to have 2 different images, a CPU and a GPU. So we'll do the CPU one first. Then we'll just repeat that with the GPU. It's pretty short. And then the following 2 here is a cost and timing sensitivity study. So there are many different instance types on AWS. So one of the first things before you really start spending hours playing with this is you want to make sure that you're using the best resources. So here we do a quick little study, find out which is the best instance for us. Because every different, especially reinforcement learning, every type of environment that you build, the resource that you need is going to change. So for instance, there might be some that is really great for GPUs, a big type of neural network. There's a lot of training. It's fantastic for GPUs. GPUs would be certainly worth the money. Some, if you have a smaller neural network and there's a lot more overhead that's going on, you might want to do something that is more CPU intensive. And then we get into hyperparameter tuning. That's kind of the last one, where we have a set of parameters, hyperparameters, that can solve this. And so this is something I've done manually. But now we're going to do hyperparameter tuning. And this is really where we're going to, make sure that we would train this is effectively the training of your reinforcement learning. Not only the training, but picking all those parameters. So we're going to go through each of these individually, and this is broken up into different videos. So the first one, actually, before we get into here, there is another video series that I mentioned earlier on YouTube. And in it, I actually go through how to set up a SageMaker notebook instance. So if you're not familiar with Jupyter notebooks and SageMaker, I recommend that you kind of go back and have a look at that video. And I'm just going to assume that you've done that. And here I'm just jumping straight into SageMaker. So in SageMaker notebook instances, I've already started one up here, just on a small T2 medium. The main thing that you do, though, is when you're creating that instance, make sure you reference in the this GitHub repo. So if you go to code here and just copy that. So when you're making that, it'll ask for a reference to a GitHub repo. And that way, as soon as it starts up the notebook instance, it'll already go and clone that repo to your local. So if you just copy that and put that in, it'll just copy this link in. So we go here. Again, I've already started it up just to save time. So I'll open it up in Jupyter. And if, for instance, you started an instance and you forgot to clone it or something like that, it's not a big deal. If you just go up here to say new and go to terminal, it opens up a little terminal on your SageMaker instance. And it always has this SageMaker folder. And in here, see, I've already cloned it, but you would just said git clone. And you clone it. So if you hit enter here, it'll go and copy this whole repo down to your notebook instance, and you can use it. So again, I don't need to do that because I put it in and already started it. So now, here's the 4 different notebooks that I mentioned. The first one we're going to go into is the CPU build. A lot of information here, and first I have to give props right down in the end. There's with SageMaker, one of the things, whenever you're doing anything on AWS or SageMaker especially, there are some excellent set of examples. So just like I think everyone should do, the first thing I did, of course, is went in and looked at the SageMaker example for PyTorch containers, and then I kind of took that, made sure I understood it, and leveraged as much of that as I could. So if you're interested, you can kind of go back here and see the original notebook that I copied to start. And a lot of the information that's here is basically copied from that. It goes through a bit of background in Docker. I'm not going to go through in this video. Again, if you're not familiar with Docker, I highly recommend going in and understanding it. It also kind of shows how when you make the instance, it basically sets up this sort of folder structure on that Docker image. And then we get into the container itself. So go back here. We can see that we have this container folder. And in the folder is got a couple really important pieces. One is build and push. So this is literally the bash commands that's required to go and build and push the image in. In particular, this is getting down and building the Docker image. You can see just Docker build, and it's either a GPU or a CPU, and then it pushes it to the ECR. So then you have your Docker image built, and it pushes in. The other one that's kind of important is your Docker file. Don't worry if you don't understand this, it's fine. I'm just kind of going through and quickly pointing out what the Docker file looks like. The really important thing here is that when you're doing it for SageMaker, you kind of have to have these environment variables set, which shows SageMaker where to go and start. So we have train.py. So this is the main Python function that SageMaker will interface with. And then it just says where is all the code. So you kind of give it the folder, and then you give it the file to start with, and it will run that. And if we just go back, we'll just quickly open up train.py, which is inside the source. And so in here, if we just scroll down, this is where it starts. And then there's a number of arguments. So when SageMaker runs, and we'll go through these later on when we start to, these are the hyperparameters that I mentioned. These are things that need to get tuned. So there's some, learning rates for the actor and the critic. There's the size of the actual neural network that you're doing. Things like that. Buffer size, gamma. These are types of things you can jump in there and kind of have a look at what they are. But these are the hyperparameters that are tuned. So when you're doing your Docker image, you just have to tell it where to start. And this is this train.py. So let's go back here, and this is again a little bit of information here you can look at, and we'll just get right into it. So the first thing it does, and actually let me just run all these while we're talking. So it goes in, it's first going to build and push this. So you can see it's going through now, literally building that Docker image and pushing it into the ECR. And it's going to take some time, so let me just pause here. Okay, so that finished up. So you can see I'll just scroll back up through a very large set of print statements here. But we can see the first thing it did, it started with that PyTorch. So there's a base SageMaker image that it grabbed for the CPU. And then from that, it just pulled everything down. Did all the installation. So there's a requirements file in here. It says, what are all the sub packages that you need to do. Install everything that it needed to do. It was in the requirements file. Then kind of created the Docker image. They were building the CPU image and then pushing it. So then it pushed it up to the ECR. Here again, very similar to how I kind of like doing it on my PC first. One of the first things we usually do is just try it on your notebook, just for a few iterations, just to make sure that everything's set up before you kind of have the overhead of spinning up a separate training instance. So this is just a little script that I'm not going to get into that sets up for local. And here's how you would set up any of these SageMaker. What you do is you create a estimator instance. So this is what this estimator, and you kind of just have to pass in your role, which gets pulled from above. Number of instances, you could do multiple instances. I'm just doing a single one. And here we're doing local. So as I mentioned, we're just going to try this locally on this notebook instance. And I'm going to grab this image, which is just the CPU. So I'm just going to grab that latest one that we have. And I'm only going to have, this hyperparameter is 200 epochs, or a number of episodes. You'll see here I kind of switch back and forth between those two words, but effectively the same. It's the number of games. We're playing tennis, so it's going to only try 200 games of tennis. That's not enough to fit, but again, I'm just trying to make sure that all of the pieces are working. And then once you create it, then you, of course, just the command word fit. So this is actually training. So it's using the similar sort of machine learning model fitting, but it's actually training. So again, it goes in, it pulls the Docker image that we have. This is the Docker image that we just created and pushed to the ECR. So it grabs that image and spins it up. And here we can see, if we scroll down, here's the number of episodes. So this is actually a print statement that's coming out from train.py, just the number of episodes and the score. And you can see we got to get to 0.5 to finish. And in 200 episodes, we haven't even got above 0 to 2 decimal places. And the average score is 0. And in this training objective, we'll note a little bit later, this is one of the things that we're trying to minimize. It is effectively your number of iterations minus and actually let me just, before I sort of say it incorrectly, because it's just right here. So it is the number of episodes times 1,000 times your mean score. So if you had 0.5, of course, it would just be minus 500. Basically, the higher the score, the better, because you're trying to minimize this. And you're trying to minimize the number of episodes. And duration. So if you have a much larger network, it might take a long time. So you got a bit of a penalty here for the durations. And that's duration in minutes. So it's time divided by 60. So if you're 10 minutes, you get 100, right, of a penalty here. So just go back in. So that's effectively the information that we're going to need a little bit later when we start doing our hyperparameter tuning. And now we're getting into actually going in, I say on SageMaker, but effectively what I really mean is that you're launching a new instance. So this instance that we had, as you remember when we started up, it's just it's a very tiny one. So you want to probably try something faster, something larger, especially when you start to move into much larger networks. Here I'm just hard coding in this MLM4 extra large instance type. And in the next one of the next videos, we'll talk about a little cost sensitivity. So before we start running a lot of these jobs, we want to figure out what's the proper instance type. I just grabbed one that I usually grab. I know it's fairly decent for this type. And again, I just ran 200 to make sure everything worked. So again, very similar to what we did before. The only difference is here I set local. And now I'm saying this particular instance. So here it's doing the same thing. It's going to take a little bit longer now because it has to actually go and spin up a new instance. So it's, starting the instance that you wanted. So it's a separate instance. And this gets really great when you start doing hyperparameter tuning, of course, because you don't have to just do one at a time. You can start doing like 10 instances at a time and just spin them all up in parallel. And the training jobs can all happen independently. And then you can come back and pick the proper hyperparameters. So as that is doing the training, I'm just going to hit pause again. Okay, so that's finished. And actually, before I go in, I just notice up here where it prints out, you'll notice the ECR image that we're grabbing, or the Docker image. It's just your account, Docker, and then it's the region that you're in, and then it's the name of your image that you created. So when we go in here, you might notice that there's about 4 minutes of just setup. The good thing is you're not charged for any of this kind of setup time where it starts up the instance, downloads the package, does all that sort of stuff. It's only when you actually get in training. And so very similar to before, this was the output that I printed. So just like last time, it's 200 images or 200 training episodes and the score of 0. And it also shows you the number of billable seconds, which is kind of nice, right? So it's, again, very, very short amount of billable time. And one of the other things we do is we go in then and we want to get the results. So if I just scroll all the way back up to here again, you'll notice that this is happening on that new image or that new instance that got trained, right? So this kind of file structure is here. So what we want to do is we want to grab that and pull it back into an S3 bucket so we could use it. Because, of course, when you shut down the image, it's gone, right? So here, that's exactly what I'm doing, where every single notebook instance that you have has a bucket. And here I'm just printing the bucket name, right? SageMaker and then my account. And this is the job. So every single training job has a job ID, and you can kind of see it's just your name of the image that you're doing and then the timestamp across it. So I go in here, I grab the output, which just gets tarred up, and I just unpack it. And then I'm just going to go in, and one thing I'm really interested in is there's a little PNG that gets created by that train.py, and I want to have a look at it. You can see it doesn't look very interesting. It's actually only have or I should say all of the scores are 0 all the way along the bottom, and there's like episode 200 out here. So not very interesting plot. Here's one where if I let it go to the full 2000 and it managed to solve this particular environment, which again, solving was get a score of 0.5, an average score. You can see these dots are all over the place, but this is the average over the previous 100. So that running mean. And it took a little under 2,000, a little over 1,700 episodes here. And this is one that I manually went in and I played with the parameters to get it to solve. So this is something I did previously. And you can see at 200, even here, it has yet to even break, 0.01. So anyways, this is the first video. I'm actually going to cut it pretty much here. It's at 20 minutes, got a little bit long. But this shows us how we put together a Docker image that has a custom training environment. So this is very similar to if you're doing any machine learning job. It's not necessarily a reinforcement learning. This is just train, right? You just call fit, and it does the fit, and we rely on all the code that we provide in our Docker image to actually set up the agent and set up the environment and all that sort of stuff. So we take care of that all within our image, and it's all custom code. And you can certainly go in and have a look at that if you're interested. But again, this is kind of just laying the foundation so that when we go forward, we'll know how to do it with a much more complex one for portfolio optimization. So with that, thank you, and I'll see you in the next video where basically I'll repeat this, but this time with a GPU instance, and maybe we'll get into the sensitivity study as well. Thanks, and have a good day.